about the solution area, solution region, which is the true region, and the corner points. So in this case, if you only have one line graph, these 2 points here would be considered our corner points. So in this case, yes, the x and the y axis are part of the corner points. And why is that, folks? Like, why all of a sudden, Mr. Dirksen, before you told me don't worry about these, and now all of a sudden you're telling me that the x and the y intercepts in this case are part of the solution? And the answer is yes. This is why, because you're always starting, when you're doing a word problem, you're almost saying that the x and the y, like you're saying that x is greater than or equal to 0, y is greater than or equal to 0. So what you're doing when you're stating that, you're actually shading out, you're canceling out all of this, right? So these are actually lines that are graphed in a sense, your x and your y axis. So when it's a word problem, you need to include the intercepts if that's the case. Okay, so that'd be one scenario. If you have a graph like this, and you happen to shade the false region, which is above the line, this is your solution. Don't forget to label your solution. In this case, you have 1, 2, 3 corner points. Okay, you've got 3 corner points in this particular scenario. If you ever have a word problem where you will have 2 lines, so let's say there's one line going like this, and one line that goes like this and crosses it there. And after some shading, right, you shade in everything above that line and everything above the other line, right? So that means that everything is gone here. So your solution region is here. So you have 1, 2, 3, 4 corner points there. Okay, so you kind of have to understand like all the points that surround the solution region, including the origin, including these points are all part of it. Okay, now let me put a twist to this one right here. Let's say, for instance, you will graph a line y is equal to something, right? Greater than or equal to something, and you graph it, it's a horizontal line. You shade this out. Now, of course, these two would cease to be corner points. It would actually be here and here, okay? So then the origin would not be part of it. So kind of always think big pictures, like what's happening here? What do I need to include as part of my corner points? And then, and so just be careful, okay? Think about it, okay? All right, so we're gonna keep going with our notes. Just gonna pause the, right? This homework, you could have kind of ignored this whole thing if that mixed you up with the test points. It should have still worked out just like before. And notice that I always label everything and then put the units down. Okay, so we did the homework. And we worked through that one question with Tukes. And then we wanted to do the cake. We're going to do the cake question now. Okay. So get your notes ready. And let's continue. So this is a second example here. A bakery has 2 options. For cakes. cake A requires 150 grams of flour, while cake B requires 75 grams of flour. The bakery has 1 point, sorry, not 1.50 kilograms of flour available. Okay.
Do you want me to make more copies of this?
No, that's fine.
Okay.
Yeah.
And so there are only 11 copies because 11 bundles. Do you want me to continue those rest of them or should I start doing one?
You can continue.
Continue?
Yeah.
Okay.
Yeah. Flour available. So the bakery has 50 kilograms of flour available. The bakery wishes to make 5 wishes to make at least 500 cakes per day. Determine all possible combinations of cakes the bakery can produce. So there's that word problem. Scroll up a bit, zoom in there. So a question, a question like this needs to be kind of looked at as the steps that I gave you, right? Like you can't just do this without putting down all those steps that I talked about, right? Like defining your variables, coming up with your inequalities, graphing them, coming up with the corner points. And it's after that where you can kind of say, okay, now I've given you all possible solutions, right? And so step number 1, if you're done with the notes, I'm hoping, step number 1, we'll define the variable. So we'll let x be what? Like you have to find out like what are the variables here. And so it should be fairly obvious at the beginning. There are 2 options for cakes, cake A and cake B. So don't just put down cake A and cake B. It's like, what are we talking about here? We're talking about number of cakes A, and Y would be number of cakes, and that would be type B. Okay, so that's what you're looking for. Okay, the second step would be to just simply state your implicit, always bigger than 0. I do look for this, okay? So you might think it's a slam dunk. Sometimes folks turn this around. right? They'll write this down. Then you're actually saying that x and y, they're all negatives, right? So that's wrong. It has to be greater than or equal to 0. And we would also have to say that this is discrete data again, okay? Because it's the number of cakes, right? So that's that. Number 3, that would be coming up with your inequalities. And here you have to be careful, okay? Maybe talk about the restrictions first, all right? What kind of, they'll kind of make a reference to, we only have up to this many of that, or you have to make at least this many of that. So look for the restrictions first, okay? So I will say, I will highlight the first restriction that I see, because they do tell you a lot about, how many grams of flour cake A and B need and so forth, but it says that the bakery has 50 kilograms of flour available. 50 kilograms of flour available. So that's a restriction right there. Okay, that's a restriction. And I will slightly reword that. I will say that up to 50 kilograms of flour available. And after a while, you won't need to do this. But right now I'm doing that. So I fished out the first restriction, up to 50 kilograms of flour available. Then there's another restriction. If you keep reading, the bakery wishes to make at least, right? Make at least 500 cakes. Okay, so we will also make sure that every restriction will end up having an inequality attached to it. Okay, make at least 500 cakes. So write that down. Okay, that's another inequality there. So we've got 2 already. And there aren't any additional restrictions mentioned. Okay. All right. You have to know that the restrictions are sometimes worded so that it's going to affect both of them at the same time. And sometimes the restrictions are stated so that it's only affecting one of the cakes, okay, not both. When it says you have up to 550 kilograms of flour available, you need to come up with your inequality, right? And because we're talking about flour, you should go up and look up what are some of the measurements that are tied to flour, right? So 150 grams of flour are used for every cake A that is being made, and 75 grams of flour is being used for every type cake B that is being made. And this combination would end up giving you the total number of grams of flour that has been used. And that has to be less than or equal to 50 kilograms. And we have a bit of a problem, right? 50 kilograms, let's convert here. 1 kilogram has 1,000 grams, right? This is how you cancel the kilograms. You always want them to cancel out. So you end up with 50,000 grams, right? So that's what we're going to put down here. So you got to make sure everything is in grams in this case, or everything is in kilograms. It's up to you. Both will work. So this inequality is now making sure we take this into account. Okay? And then you have to make at least 500 cakes. So the number of cakes of type A plus the number of cakes in type B, that combination has to be greater than or equal to 500. Okay? You're basically saying the sum, the combination of these two has to be greater than or equal to 500 because you want to make at least 500 cakes. That's probably because, to make ends meet, you need to at least have that many. So now we've come up with our inequalities. There aren't any more restrictions mentioned. Now we're going to go ahead and start to graph this. Okay. So you basically write this down. And you come up with the x-intercepts and the y-intercepts. And you're going to have bigger numbers, right? So here you have 150, x is equal to 50,000. Divide both by 150. X is equal to 333.33. Okay, so it's 333.330. The y-intercept is 75 is equal to 75y, that is 50,000, like that. Divide both by 75. Y ends up being 66.67. So that's 666.67. There it is. You've taken care of that. These ones, you will love these ones. They're very easy. If it's just x plus y is greater than or equal to 500, you're laughing, right? The x-intercept and the y-intercept is simply 500, 0, and 0, 500. That's all that there is to it. Let's go ahead and rewrite this one. It's gonna be tight here, but we're gonna make it work. Nothing flips, no sign or anything flips because this is all positive here. But you end up with negative 2x plus here I would suggest we do this, okay? To get this right. I would just say leave it as a fraction. Like that. Just leave it as a fraction, or else it will be slightly off. And I will just say that this is a solid line. Most questions are going to have solid lines. And the wording is going to be different if it's not, if it's a dashed line. And we know that the true region is below, so we will shade above. So at this point, you should know already that that's how we shade. We do reverse shading. This one is simply that rewritten. Right, I box that in. It's the solid. Above is true, so shade below. Solid, shade below. And then we're going to graph it. So maybe let's just make a note because you're going to forget, right? Leave as fraction, comma, since decimal is not finite. So this here, if you're going to put a star to explain why we did that, it's because it's not finite, right? It keeps going. And now let's graph it. I can't remember if 4 was finding the intercepts and graphing, or if graphing was a separate step, but it just naturally follows, right? So let's go ahead and graph it. So just the first quadrant, because this is now a word problem. Okay, so this is number of cake A, number of cake B. Okay, that's the first thing I'm going to do. I look at my intercepts, and I'm looking at, one y-intercept is 666.67, right? So you need to make sure you have enough room for that. I'm going to go in every which direction there. Just 1 second. All done?
All done.
Okay. Could I just ask you for one more, just to copy this, like 32 copies,
Sure.
just double-sided,
Sure.
if possible, and
Okay.
hole punched?
Okay, 32 copies.
Yeah. And that's all. If they need you somewhere else, then by all means.
I can go back to the phone, but I will make you copies.
Okay.
Yeah.
Thank you.
No problem.
You know what? Yeah. If you don't want to come all the way down here again, you can just leave them in my mailbox.
Sure.
Yeah.
That sounds good.
Okay. Thank you.
No problem. You have a nice weekend.
You too. Take care. Okay. So here we have the scales. I'm going to go, I think what makes sense is go maybe by 100. So 100, 200, 300, 4, 5, 6, 7, 8. That's plenty, right? 100, 200, 300, 400, 500, 600, 700, 800. So we have lots of room. So don't cram it too much. Okay. And I will label every other one. Okay. And then let's plot it. So we've got 333. That's right about there. 666 is right about there. So that's our first line. There you go. And this is the line 150x plus 75y is less than or equal to 50,000. Let's do the shading afterwards, okay? And also the labeling, I should have probably waited because it might be crossed out by another line. Like the other line is 500, it's right here, and 500 over here. Thank you. And there's my line here. Okay. So this would be x plus y is greater than or equal to 500. That's this one here. So I'm going to move this one. I don't like, it's too busy there. Not a big deal, right? Just fix it. So I'm going to write this over here, 150x plus 75y is less than or equal to 550,000. There we go. I can breathe again. Okay, so there we have it. And you got to be very careful not to mix up your intercepts. And now we have to worry about the shading, right? So the first line, 150, like this one right here, stick to it. It says to shade above. So let's just go for, at first you don't want to commit 100% yet because you might have made a mistake. So let's see where this goes, right? There's that. That would be the shaded of that line. And the other one, we're supposed to shade below. So if you follow this line, you're supposed to shade below it, right? So you follow that line. So everything below it is gone, right? Technically. So the only thing left is this little slice up here. So now that I've determined that it's, I'm fairly confident that my answer is correct, because sometimes everything cancels out, then you kind of know, go back, right? Go back to the drawing board and try again. So essentially, everything else is canceled, is false. It's either false for one of them or false for both, right? So everything else is out of the question. Label solution, right? You've got 1, 2, 3 points right there. I'm going to label the corner points here. And two of these are already, we know already what they are, right? So those can be read right off the, just make sure you don't mix them up. Some folks write down an x-intercept. So we just read this one, and the other one is 0, 500. We read this one, and then this one here you're going to need your calculator for. Okay, so that one is going to be worth more on a test or assessment because you need your calculator for that. So go ahead and enter those two into your calculator. Because I want to do one more, I'm just going to tell you what it is. Okay, so the answer is 166.67, 333.33. Sean, your mic is on, just so you know. There we go. All right, so we could read it off the graph. We read this one off the graph because we already did the work for that. Now we use our calculator for this. But, okay, what do these numbers represent? They represent cake A and cake B. We cannot have this, so we round it to 160. You can go down or up, it's up to you. Yeah, we can round down. Like, it doesn't matter as long as it's a whole number. I think most of you will like squint right now and say, hey, that's supposed to be rounded up, right? The only argument against that I would have, because imagine you're right here at this point, 167 puts you in the false, and you might argue that 166 will also put you in the false. So really, we will not stress about that. Just round it, and then we round this one to 333 as well, like that, because it's discrete data. Okay, so when you're finding the corner points, and you need to make sure you take that into account. So this would be 667 like this, because it's discrete, right? So you don't need to put the read, and calculator on a test. Like, that's just for your notes. So you could round it right next to it. And so now you've essentially shown all possible combinations that can be made, and you still fulfilling the requirements of those inequalities. All right. So that's that. Okay. And we're going to do another work problem. Here you go. Tom owns a metal shop and sells two different types of angle iron. And those would be aluminum and steel. aluminum angle iron sells for $2.50 per foot, while steel sells for $1.75 per foot. So they're setting the stage there, okay? Tom would like to sell at least $500 worth of angle iron, comma, but no more than 400 feet of material. Since that is the most he can store. A. Define variables. B. Write inequalities. C. Graph. D. State corner points. Okay. All right. So right now, what I want you to do is take a risk. Okay. If you don't want to mess up your notes, because I know that's always a fear, uh, do it on scrap right now because we're gonna go over it anyways. So that doesn't mean I'm just gonna wait for Mr. Dirksen. Okay, that does not mean wait for Mr. Dirksen and then I'll just do it. Right now, I want you to try this. I want you to go through the whole thing, and you have examples to guide you, right? And spend um, the most important part is to get to the write the inequalities. Okay, so the graphing and stating the corner points, if you get there, great. If not, I will give you enough time to define your variables and write the inequalities that you think are present in this word problem. Okay, so take a couple minutes. I'll say, you know, 5 to 10, depending on, right? And when you're done, just wait there and we'll continue, okay? So I'll pause the recording. All right, so Tom owns a metal shop and sells two different types of angle iron. Okay, so if you don't know what angle iron is, it's if you look at it, if you cut it across and you look at it from the end, right, it looks like this. So it's iron that is shaped like an L. Okay, so it's used for construction and the construction and the metal industry, so forth. So anyways, you sell two different types, aluminum and steel. Okay, I keep reading a little bit. Aluminum angle iron sells for $2.50 a foot, while steel sells for $1.75 a foot. Okay, Tom would like to sell at least $500 worth of angle iron, but no more than 400 feet of material, of angle iron, that is. Here, it's a little different. I think you would probably all agree that X would be aluminum and Y is going to be steel. Sure, let's do that. But you need to know, is this like entire pieces? Is this grams? Is this feet? Is this meters? Whatever the case, is this hours? What is it? We're not told that pieces are being sold. We're told that they're both sold in feet. So you have to kind of make that note that it's feet of being sold. Okay, it's a measurement. So B, write the inequalities. Before we do that, let's just go ahead and say this because somewhere it needs to appear. First of all, we can only have positive x and y values. You can't have negative feet of anything. And in this case, it's continuous. Okay, continuous because it's measured in feet. So you can have a fraction of a foot, right? So there it is. So we first of all, aluminum and steel, it came up here. We got that figured out. It's telling us that they both sell at different rates, but so far we've got no inequality there. So actually, let me just put B here. Okay. Write inequalities. To write inequalities, you have to find restrictions placed on you. Okay, so Tom would like to sell at least, so there it is, sell at least $500 worth of angle iron, but no more than 400 feet of material. Okay, so there are your restrictions. Okay, so we'll put that down. Sell at least $500 and no more than 400 feet. So we're talking dollars and feet, right? Two different things. If you wanted to sell at least 500, you're talking money. That's probably when you want to include these as your coefficients, right? So if you're talking money, the way you would figure that out would be 250 for every foot of aluminum and $1.75 for every foot of steel. And that has to be at least that combination, whatever you're selling, right, has to be at least 500 bucks. We have everything in dollars, nothing to convert. And no more than 400 feet of combined material being sold because you can't store more than that. So what you would have to say is that X plus Y, because they're both sold in feet, has to be less than or equal to 400, right? Because you can't have more than that available. So those are your two restrictions here. I wish I could add a third right now because, one thing that I could add here is that because aluminum is more expensive to ship, he always has, at least 100 feet available of that, of just aluminum, at least 100. If you did that, it would actually add a third inequality, but it would only be applied. I'm telling you this because I know already the worksheet that I'm going to give you, which will have three. Then, right, if that were the case, you would just say x is greater than or equal to 100 because don't copy this down because it's not yet. I'm just explaining. I'm expanding as we're doing this to kind of open your eyes. If it had said something specifically to uh, just the aluminum or just the steel, then it just looks like that. And this is a vertical line or a horizontal line. It depends on which one they're talking about. But if you came up with these two, congratulations, you came up with the inequalities. All right. Graph. So we're gonna do I'm gonna find my intercepts here. So 250x plus 175y greater than or equal to 5,000. x-intercepts, y-intercept. And so it's 250 is equal to 5. Sorry, why did I do 5,000? Sorry, it's 500. No, that's my bad. Divided by 250. And that's x, right? So x is going to be 200. So it's 200 0. And then it's 175 is equal to 500. Divide both by 175. Y is equal to 285.71. 0 to 85.71. I will rewrite it on the side because I know that this one will be quite easy to do. So it's 1.75 y greater than or equal to negative 2.5 x plus 500. Divide both by 1.75. And rarely in a word problem will you have to worry about flipping the sign. Okay. I think this ends up being, we'll just keep it like that. Okay, just keep it like that, x plus 500 over 1.75. We'll just keep it like that. Shouldn't worry us because we have the calculator available. Solid, and we're going to shade above is true, so shade below. Always like think twice. Like when you make that decision, it's like, wait a minute, does that make sense? Okay, yeah, got it, right? And then you move on. And then you have x plus y is less than or equal to 400. And that's 400, 0, 0, 400. No surprises there. Y is less than or equal to negative x plus 400. And this is practice makes perfect. Solid and less than. So below is true, shade above. Sometimes they're both below, sometimes they're both above, sometimes they're opposites. So there's nothing, you can't say it's always like that, okay? There's no such thing as it's always going to be like that, especially with these questions. Read, interpret, and see if it makes sense, right? Use common sense. And then we're going to graph it. So I will, sorry there, make my grid already. So this is aluminum down here in feet, steel in feet. Finally, something other than number of, right? And I'm looking at my, I'm in the 200, 400s here. So I'm going to go up to 500. So 1, 2, 3, 4, 5, maybe 6. Yeah, just for a good measure. And I go up to 600 there. And same with the Y, I need to go all the way to 400. So 1, 2, 3, 4, 5, 600. That'll do. And I'm graphing the first one, 200, 0, 0 to 85. And it's a solid line. I'm not going to label it yet. And then 400, 0, 400. There it is. The first line, it says shade below. So I'm going to shade below. Second line, it says shade above. Well, shade above. So it's everything shading above. Okay. So it's everything above that line, everything below this line. So my solution is here. Look at that, right? It's different than what we've seen so far. And oh yeah, I need to label, right? So this would be x plus y is less than or equal to 400. This line right here, I'm just going to label it that way, 250x plus 1.75y is greater than or equal to 500. And there it is, corner points. In this case, they're all just reading it off, right? So I'm going to start here, 0, 400, 0, 285, 71, and I don't have to round. 200, 0, and 400, 0. Those are my corner points. No need to round. Because data is continuous. So there you have your corner points. So you have all possible combinations on this graph, and that is that. So if you could go through your package right now, your handouts. I didn't keep enough back. I gave them all out. I'll do one last look at it. Oh no, I do have one here. I will ask you to do examples 1, 3, and 4 in handout. And I don't have a name for that handout, but I will show you what it looks like, and I will also post it for those that don't have it, okay, that for whatever reason didn't come through here and didn't get it. And this is the handout, okay? It looks like that. It's like a folded handout. It has a fold on it. Do not do question 2 unless you're up for a challenge. If you like a challenge, you should try question 2, but do it at the end. I will tell you this. You know how I was talking about restrictions that are only set on one of them? Sometimes they both have their own restrictions set on them, so that results in a horizontal and a vertical line. It will show up. So I can tell you this. I will tell you this much. This one will have 3 inequalities. Right? So if you look at the very first example that I want you to do, that one will have 3 inequalities. I can tell you that already. Skip 2, that one is pretty crazy for now. This one has 2 inequalities. So example 3 has 2 inequalities. And example 4 has 3 inequalities. All right, so keeping that in mind, okay, that's your homework. I will post the answer key to that as well. And then you will know am I on the right track. But don't peek until you've tried it. Okay, I need you to start problem solving based on what you've learned. Okay, So with that being said,